All right, let's get right into it. Today, we're going to pop the hood on Linux administration. By the time we're done here, you'll have a solid blueprint of the core principles that make these amazing systems tick. So let's get started.
You know that feeling, right? You're staring at a Linux terminal, just a blinking cursor, and you kind of wonder, what is really going on behind all this? What are the essential bits and pieces, and how do they all connect? Well, that's the blueprint we're going to lay out today.
So, to really get our heads around this, let's break down any Linux system into three main parts. It's kind of like a vehicle, right? You've got the engine doing all the heavy lifting, the cockpit where you're in control, and a toolbox with everything you need for the job.
When you boil it down, a Linux system is beautifully simple. First up is the kernel. That's the engine, the absolute brain of the operation, managing your CPU, your memory, all the hardware. To actually talk to that kernel, you use the shell. That's your steering wheel and your gas pedal. And finally, you have the utilities. These are all the tools in the toolbox that actually get stuff done.
So where does all this stuff actually live? In Linux, there's one simple, elegant rule. Everything is a file, and every single file and folder starts from one single point, the root directory, which is just a /. That's it. The entire system branches out from there like a tree flipped upside down.
Let's do a quick whirlwind tour of this system-wide filing cabinet. /boot, that's where the ignition keys are. It holds the kernel itself and what it needs to start. /var is for variable data that's always changing. Think of it like the system's logbook or attic. /usr is the main software library where most of your programs live. /etc is the central control panel, full of configuration files. And of course /home, well, that's your space. It's where all the user files go.
Okay, so we've got the components, and we know where things are stored, but how do we actually do anything? This is where the real fun begins, with your command toolkits.
So, let's start with a classic. You want to see what's in a folder. You type ls-l*.txt, boom. You get a detailed list of every single text file. Simple enough. But what if that list is a mile long and you're only looking for files that have the word report in them?
And this is where the magic really happens. It's one of the most powerful concepts in Linux, and it's called the pipe. See that vertical bar? It literally takes the entire output from that first command and just pipes it right into a second command, grep, which filters the text. So instead of a giant list, you only see the lines you care about. This idea of chaining small, simple tools together is the heart and soul of the Linux philosophy.
Speaking of power tools, you have got to know about the find command. This thing is an absolute workhorse. It doesn't just find files by name, you can track them down by their size, when they were last touched, who owns them, you name it. And the real kicker? You can tell find to run another command on every single thing it finds. This is how you automate massive jobs across your whole system.
Now with all this power at our fingertips, you can see how things could get out of hand pretty quickly, right? So controlling who gets to do what is, well, it's absolutely critical. This brings us right to the heart of system security, users and permissions.
At first, Linux permissions can look a little cryptic, but I'll let you in on a secret. It's just really simple math. You only have to remember three numbers. Read is 4, write is 2, and execute is 1. That's it. Just burn 4, 2, and 1 into your brain.
So to set the permissions you want, you just add those numbers up. You need someone to have full control? That's read, write, and execute. So 4 plus 2 plus 1 gives you 7. What if you want them to be able to read and run a file but not change it? Well, that's read, which is 4, plus execute, which is 1, and that equals 5. This simple system is exactly where those famous permission codes like 755 come from.
Okay, so what if you need to do something with admin privileges? You're not going to log in as the all-powerful root user all the time. That's just asking for trouble. Instead, you use sudo. It's like saying, please run this one command for me as the super user. It's a fundamental piece of security because it lets you give out specific powers without ever handing over the keys to the entire kingdom.
And the security actually goes even deeper. Those permissions we just talked about, that's called discretionary access control. It means the user who owns the file has the discretion to change its permissions. But many modern systems add a second, much stronger layer, mandatory access control, usually through something called SE Linux. Think of SE Linux as a system-wide security guard that enforces a strict policy that no one can override. So even if a hacker compromises a program, SE Linux steps in and contains the damage.
A Linux box sitting all by itself isn't very useful, is it? It needs to connect to the outside world. So
let's take a look at a few of the essential network services that make all that communication possible.
So where does a connection even start? Well, before your system can talk to anything else, it needs an address. That's the whole job of DNS, the domain name system. It's basically the entire internet's address book. It translates a human-friendly name that we can remember, like google.com, into a numerical IP address that computers can actually use. Without this first step, nothing else happens.
Once DNS gives you that address, you connect to a web server, and chances are that server is running Apache. Apache's killer feature is something called virtual hosts. It allows one single server to act like it's hundreds of different websites all at once. It just looks at the domain name you requested and directs your traffic to the right place. Super efficient.
But sometimes your request doesn't go straight to the server. In a lot of big networks, like at your office or school, you might first talk to a proxy server, like Squid. It's basically a middleman. It takes your request, goes out and gets the content on your behalf, and brings it back. This is great for security, for controlling what websites people can visit, and it can give you a huge performance boost by caching popular stuff.
All right, let's bring it all the way down to the physical foundation of everything. How your data is actually organized on the storage drives. It's time to master our disks. Before you can even use a disk, you have to partition it. Basically, slice it up into usable chunks. For years and years, the standard was MBR, but it had some major limitations, especially with disk size. Today, the modern standard is GPT. It's way more robust, it supports absolutely massive drives, and you can have a ton of partitions. Honestly, if you're setting up any new system, there's just no debate. You use GPT.
But what if you want more flexibility than fixed partitions? That's where LVM, the Logical Volume Manager, is a total game changer. There are just 3 building blocks to remember. First, you have your physical volumes. Those are your actual hard disks. You combine one or more of them into a volume group, which is basically one giant pool of storage.
And that right there is the key idea. With LVM, you can take several different physical drives and just tell the system to treat them all as one massive storage pool. You're no longer limited by the size of a single disk. And from that giant pool, this is where the real magic happens. You carve out logical volumes, which act like partitions in any size you need. And the absolute best part? If you start running low on space in one of them, you can just expand it on the fly without any downtime. It's an incredible amount of flexibility that you just don't get with standard partitions.
So there you have it. From the kernel to the file system, through commands, security, networking, and all the way down to disk management, you now have the blueprint for how a Linux system is put together. All that power and all that flexibility, it's all built on these fundamentals. So the only question left is, what will you build with it?